Welcome to Transistor Amplification High Frequency Cutoff Calculations. Here's a universal biased common emitter amplifier. In this video we're going to go through how to calculate high frequency cutoff. Here's the AC redraw. You can see the DC's power supply is acting like an AC ground. The coupling caps are acting like shorts. And now we've included R', the AC resistance for the transistor. Now let's consider the device capacitance of the transistor. So we've got two new capacitance to look at. We've got CBC, which is the capacitance base to collector, and CBE, which is the capacitance base to emitter. Now CBC is approximately equal to CIBO. CIBO is the input capacitance included on the data sheet, so you need to look that up for the transistor that you're working with. And CBE is equal to 1 divided by 2 pi R' times the gain bandwidth product, which is FT, which is also in the data sheet. So now we can find the capacitance base to ground, or CBG. And CBG is equal to CBE times quantity 1 minus the gain of the amplifier if it was in the common collector mode. And we can find that simply by dividing RE by RE plus R'E. Now we've got two capacitance to consider, C Miller in and C Miller out. And C Miller in can be found by multiplying CBC by the quantity 1 plus the gain of the transistor or the amplifier in the common emitter mode. C Miller out can be found by multiplying CBC by the quantity 1 plus the gain, common emitter, divided by the gain, common emitter. Now let's talk about straight capacitance. Straight capacitance will be seen on the output and on the input, and that should be about approximately 10 picofarads. And then of course, if you hook your probe to the output and you're measuring, you're going to see approximately 16 picofarads also. You will also have some generator capacitance that you're just going to have to look up in your specification or your user manual. And all this is getting pretty complex. This is getting to be this giant circuit with all these high frequency capacitance here. But we can simplify all this because we know that capacitance in parallel add. So we can add up all the input capacitance and all the output capacitance and simplify this circuit a little bit. Here we've added up all of our input capacitances and our output capacitances, and we've got a C total in and a C total out. Now we can Thevenize from those two capacitors and find an R Thevenin in, or C total in, and a R Thevenin C total out. We can use our R Thevenin C total in now and our R Thevenin C total out to calculate FC high in and FC high out. Here's our final formula for calculating FC high total. We've arrived. So it's 0.35 divided by the square root of the quantity 0.35 divided by FC high in squared plus 0.35 divided by FC high out squared, and that gives us our final FC high total for the circuit.